This particular activity has a rich history in the story of mathematics. So the story goes that an ancient king was looking for a new game, and he put out a competition for people to create a new game for him. And one of the games that was created was the game of chess. Now the king was so impressed with this game of chess that had been created that he allowed the inventor to choose his prize. Now the inventor was a wise man, and he decided to choose something that would not look like he was asking for too much, because he knew if he asked for too much, even though the king said that he could choose what he wanted, it might not go down too well, and he might end up being beheaded. But he also wanted to get as much as he could. So the wise man asked for 1 grain of rice for the first square of the chessboard, 2 grains of rice for the second square of the chessboard, 4 grains of rice for the third square, and so on, doubling the number of grains of rice for each subsequent square until the whole chessboard was filled. Now the king readily agreed to this because he thought, that's not very much. That looks like a really small number of grains of rice. That sounds really cheap for this fantastic game of chess. But the wise man was very wise, and he knew that this would actually lead to a very large reward. So the question is, how many grains of rice are there on the chessboard in total? So let's begin by thinking about what it is we actually want to calculate in terms of sequences. We want to calculate what 1 plus 2 plus 4 plus 8, and keep doubling all the way up to the 64th term of that sequence, because there are 64 squares on a chessboard. Now, to give you an idea straight away, we can work this one out, because this is the 64th term of a geometric sequence. So un for this geometric sequence is 1 multiplied by 2 to the power of n minus 1. So u64 is equal to 2 to the power of 63. And that is 9.2 times by 10 to the power of 18. That is a very, very large number already. In fact, that is more than there are grains of rice in the world. But that wasn't actually what he asked for. What he asked for was the sum of all of these things. So how could we work that out? Well, let's start by looking at the sums and look for some patterns. So S1, sum of the first term is 1. S2, the sum of the first 2 terms is 3. S3, the sum of the first 3 terms is 7. S4, the sum of the first 4 terms is 15. And if you compare these to the numbers in the sequence, you'll actually see they're all 1 less than a power of 2. This is 2 minus 1. This is 4 minus 1. This is 8 minus 1. This is 16 minus 1. So that would suggest that Sn is equal to 2 to the power of n minus 1. Well, but this is a suggestion. This is a conjecture. We haven't shown this to be true. So let's think about how we could show this to be true. So we're going to start with our series again. I'm going to call it S, and it's equal to 1 plus 2 plus 4, sorry, not 3, plus 4, plus all the way up to plus 2 to the n minus 1. And beneath that, I'm going to write the same thing, but I'm going to double the whole thing. I'm going to write 2s. So 1 multiplied by 2 is going to be 2. I'm going to write that there. 2 multiplied by 2 is going to be 4. I'm going to write that there. 4 multiplied by 2 is going to be 8. And this is going to carry on going. Something multiplied by 2 is going to be 2 to the n minus 1. And 2 to the n minus 1 multiplied by 2 is 2 to the power of n. Now what we can do here is we can subtract the first one from the second one. If we do that, we do 2s minus s on the left hand side, and on the right hand side we get all of this one minus all of this one. But there's a lot of crossover here, because all of these ones appear in both. So when we do the subtraction, all those ones are going to cancel out. So we just get left with 2 to the n in this one, and from the one above we have got subtract 1. 2s minus s is just s, so we end up with s is equal to 2 to the n minus 1, showing the result that we conjectured. So in total, how many grains of sand were there on the chessboard? Well, we were looking for S64, so that's 2 to the power of 64 minus 1, which is approximately equal to 1.8 times 10 to the power of 19. An absolutely ginormous number, completely impossible to actually work out. And this story shows how mathematics can be used to see something that doesn't look like it's getting that big and suddenly gets very big very quickly. And that's essentially what happens with geometric sequences and series. In the next video, we'll have a look at how we can generalize this method for any geometric series, not just this specific one.